Hello, this is Tommy. Welcome to Chatomics. Today I'm going to show you how to add percentages to the y-axis of a bar plot and how to order the bar plot by the value of each bar. So to demonstrate this, we're going to explore how many genes in each chromosome in the human genome. And to do this, we will need a genome annotation file where we can get all the locations of the genes in each chromosome. So luckily, in bioconductor, there's a package called txdb Homo sapiens ucsc.hg19.known gene, which contains all the gene information that we can use. So by the way, if you don't know UCSC Genome Browser, make sure you check this link. I remember when I was in the wet lab, I went to the UCSC Genome Browser a lot. There are a lot of gene regulation tracks that you can explore whether a transcription factor is binding to the promoter of your favorite gene or not. Okay, let's first load those libraries. And here we just assign this long variable name to a shorter variable name. And we see this txdb is a txdb object. It's created by the genomic feature package in bioconductor. So I highly recommend you to learn how to use this genomic features bioconductor package. So in this package, there are functions, for example, genes, and if you give the txdb as the argument, it will return all the genes in the human genome. So let's run it. So it returns a genomic ranges object, and now each row is one gene with chromosome name, start, end, strand, whether it's or minus or plus, and gene ID. So similarly, you can use the exons function to return all exons in the human genome. So now each row will be one exon. So chromosome start, end, the strand, and the exon ID. So to plot anything in ggplot2, we need to turn it into a data frame. And I'm using this as data frame to turn this genomic ranges object into a data frame. And I'm going to take a look at the first 6 rows by using the head command here. Okay, now this data frame is ready for you to plot. Okay, let's save this data frame into a new variable name called genes_df. Okay, now we can count how many genes in each chromosome by using a function in dplyr called count, and you give a column name, sig names here. It will count how many genes in each chromosome. So let's do it. So it returns a 2-column data frame, the chromosome name and the number of genes in that chromosome. So by default, the name of the new column will be N if you didn't specify it. We'll also notice that there are some unconventional chromosomes that you might want to remove. So to do this, we first created this conventional chromosome new variable, it's a vector, by using the paste0 function. And if we look at this, the value of this vector, chromosome 1 to chromosome 22 plus XY, those are the conventional chromosomes. So now we can check how many total genes in the human genome. So we filter the chromosomes that are only in the conventional chromosomes and use n row to find how many rows or how many genes in that data frame. So if we look at this variable, okay, 23,000 genes in the human genome based on this particular reference. Now we can count how many genes in each chromosome by using the same command, count sig names, but after we filter out all those unconventional chromosomes. So let's do this. Okay, and we can take a look at the value of those this data frame. So now only contains the conventional chromosomes and the number of genes in each chromosome. So we need another extra column to show the percentages. So we will use mutate function from dplyr, and this is the new column name, genes percent equals to number of genes in that chromosome divided by the total number of genes in the whole genome. So let's do that. Okay, we have another column for the genes percentage. Okay, now we're ready to plot. So notice that this is the same line as here, and I just pipe it into ggplot2 for the plotting. So when you have a long actual commands, always test the code a little bit by bit. So now I pipe it into ggplot2. The x-axis will be the seq names, the y-axis will be the genes percent, and using geometry bar, and stat equals to identity because we want to plot this column as is. So let's try it. So this is the bar plot. It's pretty nice looking already, but there's several problems. For example, those chromosome names on the x-axis, they kind of overlap with each other, and probably we don't need the seq names label here. So what we do, we want to actually use the X label and use this empty string to remove the seq names, and use this theme function and rotate the labels on the x-axis. So by the way, if you don't really know how to do this, don't worry. Like actually, I just Googled and found how to do it on Stack Overflow. Okay, let's do it. See, now the chromosome names rotated here, and it's much cleaner. And personally, I like to use the black and white theme and increase all the font size to 14. So the same code as before, I just added this extra row here. And this is the figure after we use theme black and white. So there's one more problem. So we want to actually change the y-axis to percentage. So here should be 10%, 7.5%. And to do this, you only need to add one more line here. So it's the same code chunk as before, but you add this one more line, scale y continuous, and use the percent function in the scales package. So labels equal to scales dot 2 colon and percent. So let's see how it looks. So now the y-axis becomes a percentage as expected. And we see chromosome 1 has the most number of genes, and chromosome 1 has the lowest number of genes. So to make the bar plot look a little bit better, we can order those bar plot by the value of the y-axis. So to do this, we need to change the factor levels of the seq name and the chromosomes by using a function called fct_reorder in the forcats package. So forcats is part of the tidyverse ecosystem, so you can use it to easily change the order of the levels of the factors. So I highly recommend you go to this link and check it out. So we change the seq names of the chromosomes, the levels by genes percent, and by default we'll reorder it from small to big. So the rest of the code is the same as the last chunk. So let's see how it looks. See now, you see the bar is reordered from small to the largest. So default is the order is small to large, and we can actually reverse the order by adding this extra argument dot DSC descending to true, and it will reverse order of those bars. Okay, that's it for today, and I hope you like it. And make sure you check the video description to get all the links for this R Markdown file to follow the tutorial. Happy learning!